In this lesson, we're going to talk about quadratic functions and optimization. So like we said, optimization, that's making something the best that it could be, getting the most out of something. This particular question, which is the first one on your sheet, says a sporting goods store sells reusable water bottles for $8. At this price, their weekly sales are approximately 100 items. What are they going to try to optimize here, do you think? Their sales, but not just the sales, it's really the amount of money that they're making, right? That's what a store wants to do, is make the most money that they can. So right now, they're selling them for $8 and they sell about 100 a week. Research says that for every $2 increase in price, the manager can expect to sell 5 fewer water bottles per week. So really what we want to know is, should they be charging more or less than they're currently charging? What would happen if we look at, first of all, how much money are the water bottles bringing in currently in 1 week? Let's look at that. 800. What if they increase the price by $2? 1,000?
$200 increase in the sales.
Oh yeah, because they go less.
What would it be? 9,500? 950? Let's calculate it. So first we did, it was easy the first one, right? Because it was $8 and multiplied by 100. That gives you 800. But then if you increase it, they're going to be $10. But how many are they going to sell? 95, right? So $10 times 95. So 950? 950. So should they increase the price? Yes. Our goal is going to be to figure out how much should they increase the price by. Should they increase it by $2 or $4 or $6 or $8 or $10 or 100? Or we don't know yet. But that's what we're going to find out in this question. So the first one says, represent this situation with a quadratic function. When we want to write a quadratic function, we need to write a function for whatever it is we're trying to optimize. And in this case, it's revenue. Do you know that word, revenue? What's revenue? Income. Yeah, it's not net income, but it's a type of income, right? It's the total amount of money that's brought in, not including how much it costs them to buy the water bottles or to rent their store space or whatever. It's just the amount of money that's coming in from water bottles. And revenue is going to be equal to the number that they sell multiplied by the cost per item, right? That's what we did at the top, 8 times 100. 8 was the cost per item. And then the 100 was the number of items sold. That's going to be the basic equation that we use, but we need to figure out what is it that is varying. What's the variable here? So what are we changing? The number of water bottles?
Cost per item.
And the cost per item, right? We're changing both of them. But really remember what we're trying to figure out is how much should they charge? How many times should they increase the price? So the variable is actually going to be the number of price increases. So let's put that down as well. I'll move that up. And I'm just going to say x equals number of price increases. So it's how many times they increase the price. Now we want to look at how the revenue changes. originally, the cost per item was $8. But what's going to happen as they vary the price? For every increase is $2. So we're going to add 2 to that. How many times do we add 2? X, right. And when that happens, when we increase by 2 and then 2 more, 2 more, 2 more, what happens to the number of items sold? Subtract 5. So it started out as 100, and we're going to subtract 5x. Because for every time you increase the price by 2, you decrease the number sold by 5. Is that a quadratic function? Yes. Because if you expand it, do you see where that x squared term is going to come from? Yeah, that's a quadratic function. Once we have that, then we're going to rewrite the function in vertex form. I have this problem broken down into multiple steps. When you have, if you just take a quick look at the second question, you're just going to have a question, and it's not going to be broken down into steps, but these are the same steps that you're going to follow. So rewrite it in vertex form. Who thinks they know what to do first? Expand? Did somebody say that? I think that's what we should do. Let's expand it. So we'll do 8 times 100, that's 800. And then 8 times negative 5x, which would be negative 40x. 2x times 100, so plus 200x. And then 2x times negative 5x, negative 10x squared. So actually what I'm doing right now is just putting it into standard form. Standard form will look like this: negative 10x squared plus 160x plus 800. So now remember, factor out the coefficient from the first 2 terms. So just from here, the coefficient on the first term is negative 10, so I'll take that out. This will become x squared minus 16x. I'm going to leave that space so that I can complete the square. And the plus 800 is outside the bracket because I didn't factor out the negative 10. To complete that square, half of 16 is 8. 8 squared is 64. So we'll go plus 64 minus 64. And then I can factor just this part of it, which would give me x minus 8 squared. And I'll take the negative 64 out, but when I take the negative 64 out, I have to multiply it by the negative 10. So it's actually plus 640 and then plus 800. So our vertex form is negative 10 x minus 8 squared plus 1440. This question continues with, what does the vertex represent in this situation? So we need to think about what the vertex is and what it represents. First of all, just easy question, where is the vertex? 8 and 1,440. What does that represent in this situation? What was the x? Again, we defined it at the beginning. Number of price increases. So how many times are they going to increase the price? 8 times. What does the other number represent? No. Revenue, right? Because remember, the equation was r equals negative 10x squared, whatever, or it's right there. The first value is the x value, the second value is the r value. So really what it represents is the number of price increases that will result in the maximum revenue. The vertex represents the number of price increases that will result in the maximum revenue. How do we know that that's the maximum? It's the highest point on the graph, right? This is a quadratic function that opens down. Something like that. The vertex is that point right at the top. That's the highest revenue, the maximum value. So what price should the manager set for the water bottles?
$24.
Who's going to buy a $24? This one says, a farmer wishes to build a corral with 100 feet of fence. Hoping to maximize the area of the corral, he will build it against his barn using the wall of the barn as one side. So he only has 100 feet of fencing. He wants the biggest corral he can have. So instead of making a rectangle, he's only going to build 3 sides of fence. So it's going to look like this. Here's the barn. And then he's going to build a corral on the side of it like that.
We're assuming the barn is as long as it needs to be.
What are we trying to optimize in this situation? Or maximize? Area, right. What shape do you think the corral is going to be? What did I draw it as? A rectangle. It's going to be a rectangle. How do we find the area of a rectangle?
Length times width.
Okay, that's a good place to start. Area is length times width. We need to figure out how to use the information that we're given in the question to make a quadratic function for area. Because remember, the function is always written for whatever we're trying to optimize. We're optimizing the area. So the function is going to be A equals something. And we want to do length times width. But those are 2 different variables, and we need to somehow make it into one variable. So I'm going to use W for the width. This is W here. But I need to figure out what can I call the length with respect to W. Because I can't use an L and a W. So I need to define the length with respect to the width. There's one piece of information left in the question that's going to help us do that. So both of these sides is W. You have 100 meters, feet, was it? Yeah, 100 feet of fence altogether. So if we use W on one side and W on the other, we're left with 100 minus 2W for the length. Now we can write the quadratic function. Area is equal to length times width. Length is 100 minus 2W. Width is W. And there's the quadratic function. In what we call factored form, which we don't really work with a lot, although we will in the next unit look at factored form of quadratic equations. I want to rewrite it in vertex form, so I'm going to start by expanding it. (100 times W, negative 2W times W). So we get negative 2W squared plus 100W. I chose to use W because I'm using it for the width. You don't have to use that. If you would rather work with X's or some other letter, that's okay. And I didn't write out a definition of what W represents. I just drew it on a diagram, which is going to be good enough, as long as it's clear on the diagram what W is. You could write W equals width and 100 minus 2W equals length, if you want it to be really clear. Let's do this. Factor out the negative 2. That's going to be W squared minus 50W. So to complete the square, half of 50 is 25. 25 squared is 625. So we'll go plus 625 Remember, it has to be a zero pair, so we'll also subtract 625. This is going to be w squared minus 50w plus 625, and we'll take the negative 625 out, but it has to multiply by the negative 2 that's in the front, so that becomes plus 1,250, right? Negative 625 times negative 2. Finish it off by factoring. W minus 25 squared plus 1,250. The next part asks you, what does the vertex represent in this situation? First of all, the vertex is at 25 and 1,250. What does it represent? What's the x in the x spot? Oh, I used x on here, but it's actually w, right? So it's the width. So the width is going to be 25. What's the 1,250? The area, right, because it's an area equation with respect to width. So the vertex represents the width that should be used to optimize or maximize the area. You don't always need to write that down, but you should always think about it. Think about what the vertex represents once you find the vertex. You don't necessarily always need to write a sentence about it, but it should be something that you always think about. What are the dimensions of the corral that the farmer should build? Well, the width's going to be 25. 25 by 50. How did you figure out the 50? There's kind of two different ways you could do it. How do you know it's 50? She says you have 100 feet of fence, you take 25 for each side, you're left with 50, right? The other thing you could do, if you know that the width is 25, take the area, divide by the width, that'll tell you the length. So 1250 divided by 25. The dimensions of the corral, it's going to be 25 feet by 50 feet. 25 feet in width by 50 feet in length.